So we're going to be discussing today the implications of green technologies for environmental justice. And before we get started, a huge thanks to our platinum sponsor, Rheem. They have heat pump water heaters that are really the future of water heating. They take natural heat out of the air and use it to heat water with zero emissions directly up to 400% efficiency. They offer a hybrid water heater with backup electric resistance at 240 volts to ensure hot water all the time, or they have 120 volt systems that quickly replace existing gas in many cases without the expensive electrical upgrades. They work by pulling heated air through a filter, and it's absorbed by an R410A refrigerant using a compressor to heat coils wrapped around the tank. These are also approved for Inflation Reduction Act tax credits up to $2,000. States will have rebates for these coming off the top. And there's $600 for electrical systems improvements and tax credits and other rebates potentially if needed. And again, if you're not ready to go full heat pump, there are all electric tank water heaters from Rheem, and they have time of use demand response programs to help you still stay decarbonize without having to go for that full heat pump system. Check them out over at rheem.com, heat pump water heaters. And second, thanks to our silver level sponsor, Panasonic, who helps meet all of your ventilation needs from supply to smart and recovery. Check them out over at Panasonic. So again, welcome to implications of green technologies for environmental justice. This course is brought to you by the Green Home Institute. Green Home Institute is a nonprofit with a mission to empower people to make healthier and more sustainable choices in the renovation and construction of the places we live. We're a small but mighty team of 3, and today I'll be your moderator. My name is Brett Little, and I am the education manager here. This course is approved for multiple continuing education units, including our Certified Green Home Professional designation, 3 pillars there: place, health, and energy. AIA, Health, Welfare, and Safety may make it applicable to your state-based design or contractor license. And then make sure to check out the Passive House code at the end with the 5-digit certificate, 5 digits that you'll need on your certificate. So with that, I am excited to welcome our guests here today, who are also board members at the Green Home Institute, Parth and Adewale. And Parth, I think now this is probably your 3rd time maybe on our show. So it's always good to have you back, especially as a board member, and appreciate your time. So Parth, I'm going to have you quickly introduce yourself, and then Adewale will do the same for you, and then Adewale is going to take us through a couple of things, and then we're going to hand it off to Parth for the main presentation. So Parth, go ahead.
Good morning, everyone, or good afternoon, everyone. My name is Adewale Adesanya, and I am the chair of the Education Committee of GHI. Been in the board for 3 years now. And I mean, it's been wonderful to keep, serving on the board and then helping with, webinars, weekly webinars like these, and supporting the work of GHI. So, and then today, while Path is still working on his sounds, I just wanted to by a way of introduction, bring you up to speed on some existing global and national policies with respect to the topic that we're looking at, which is implications of green technologies for environmental justice. And then, from this introduction, I will be passing the baton to Path, who will take us, and deep dive into some of the existing problems, with respect to environmental justice, and then what we have. So the first thing is that, it is expected that green technologies will play a critical role in mitigating underlying environmental justice and climate-related problems and impact in the society. And never before have we seen unanimous interest, across the globe for the push for equity and justice, as we tackle climate change problems headlong. We're seeing global policies and decision makers, talking about, that. So today I just wanted to talk about, why this is important. Thanks, uh, um, Brett, for switching to the next slide. So we want to talk about why this topic is important. Why are we, considering this topic? What should we, as individuals and as business owners, what should we be looking at? What should be our target? So the first thing, is to understand the drive, the direction in terms of policies and programs and initiatives, both locally, nationally, and internationally, that is driving clean and green technology, adoption. And one, key policy is, the national at global level is the UAE consensus, at COP28 in Dubai, where you have, declaration and commitment of the world to fast track a just, orderly, and equitable energy transition. And then, this was at the United Nations annual climate change conference. For those of you that are not aware, the United Nations annual conference is where you have, leaders. Can you go to the next slide, please? On who attends, the conference, it's usually attended by, leaders across the world, 150 head of states and governments, civil societies, businesses, indigenous people, youth organizations, philanthropies, international organizations, and then they discuss pertinent issues with respect to, tackling, climate. And interestingly, the last year's COP, it's called COP. COP is the full the full meaning of COP is Conference of Parties. So parties are head of states that are parties, to signing all the policies and programs and plan and decisions to tackle national climate issues. So this last COP was attended by over 85,000 participants, which is the biggest of its kind across the globe. And then we've seen a lot. And next slide, please. So in this year's or the last year, because now we are in between the last year's COP28 in Dubai and then COP29, which is going to be happening in Azerbaijan. So the consensus, as we are in the middle of the last year's discussion and consensus, is that over 130 countries agreed to and endorsed tripling up on renewable energy by 2030. And then the implication, the meaning of this is increasing renewable generating capacity by at least 11,000 gigawatts, which is an indirect statement on, the need to phase out fossil fuel, and, begin to work on sustainable, making our energy systems and the environmental more sustainable. So energy and environmental justice is gaining more traction, across the globe. And one, as a participant of the conference, a regular participant at the COP, is that never like before I've personally seen a lot of focus on community and equity focused programs and initiatives, which was very popular all through the conference. You go to different sessions and you see a lot of talks, a lot of discussions with respect to making the transition equitable and just, programs on a local level and at national level that's being, targeted towards making it, equitable and just. So next slide, please. So on the national level, speaking on U.S. policy, we've seen a lot of moves, a lot of actions that the government is taking. And then before we go into that, what is, it's important to, see the definition of the Environmental Protection Agency on environmental justice, which entails taking deliberate and intentional efforts to ensure that people, regardless of their income, race, color, national origin, tribal affiliation, or disability, are given just treatment and protection from economic activities that are harmful, to human and the environment. And, essentially the idea of environmental justice rests on the fact that environmental harm is, inequitably distributed and influenced by patterns of some sort of, racial and inequality, racial discriminations and inequality. So in other jurisdictions, we've seen, and also in research, we've gotten reports on equitable actions, which are more towards a qualitative approach, which includes community engagement, decision making, but we've seen less of empirical cases of quantifying equity and justice, across, the environment and across how, the programs that are being done. So the US with the Justice 40 initiative, as some of you will know, represent the federal government's goal of ensuring that 40% of the overall benefits of all federal related climate, energy, and affordability and sustainable housing programs and investments flow to the disadvantaged communities that are marginalized by underinvestment and overburden by pollution. So this is an intentional effort by the government to ensure environmental justice, and then the implementation is also being seen across many states. You speak of California, New York State, and all other states that have already enacted some form of climate acts, and then we'll see all that progressing and gaining a lot of traction. So I'm going to be switching or giving the baton to Path, who will be diving deeper into what this implication of clean energy transition means and making it more equitable and just. Is going to be giving us the deeper empirical research on some of the things that we're seeing with respect to inequities, and then a problem related to clean technology implications in our society. So over to you, Path.
Thank you very much, Adi, and hopefully this is working now. I promise everyone we did do a sound check.
Yeah.
I will quickly share my screen and then introduce myself. I'm Parth Vaishnav. I'm an assistant professor at the School for Environment and Sustainability at the University of Michigan. A lot of the work I do is related to the decarbonization of the building and transportation sector. Adi, I really appreciate that you started with first framing the problem so well, but also with a discussion of the EPA's definition of environmental justice. Now, that definition includes the three dimensions that you see here, which is exposure to environmental harms. And there was seminal work in this area done by my colleagues here at the University of Michigan, uh, Paul Mohai and others, many years ago, which is summarized in this review here, which you can freely access. What this study will talk about, building upon past work, is justice in access to green technologies. So if we decarbonize, and if we want to fully decarbonize, it's not sufficient that these technologies are accessible to a small proportion of the population. They have to be accessible to everyone, and they have to be accessible in a way that does not cause those people additional harms or unforeseen harms. And work in that area was reviewed in this paper that is shown here, which you can also freely access. And in that paper, I talk about a number of different technologies which we believe are necessary for decarbonization in the building sector, in the power sector, in the transportation sector, and in industry. I, in fact, didn't talk about industry because it's a sector where individuals don't have access to technologies. Individuals can't make decisions. But I did talk a little bit about all the other sectors that are talked about here. I talked about how infrastructure and policies affect environmental justice, affect people's ability to access these technologies. And I talked about the outcomes in terms of environmental justice along different dimensions. Is access to these technologies equitable to people of different races? Is it equitable to people in different places? Is it equitably available to people with different incomes, with genders, and with people who have disabilities and those who don't? So obviously, this is a 30 or 40-page paper, and I don't want to go through all of this, especially at lunchtime when it's sort of guaranteed to put people to sleep if I went through all of this. So normally when someone presents an academic study, it's usually like a novel. You have a beginning, a middle, and an end in the study. In this case, this is going to be a little bit more like a series of short stories, maybe even a series of cartoons, where I talk about case studies which show how infrastructure and policies influence the extent to which people have equitable access to green technologies, mostly in the United States, but also across the world. And to organize this a little bit so that you're not just getting a series of vignettes, I'll start by describing the 4 key takeaways that I hope you'll get from this talk. The first one is that those disparities in access to new technologies occur across multiple dimensions. Those dimensions were summarized here. There's race, there's income, there's disability, there's place, there's gender. So these disparities occur along multiple dimensions, and often these disparities can be particularly acute at the intersection of some of those dimensions. So for example, income and gender. I'll show in a couple of, using a couple of case studies that low-income women have particularly poor access to green technologies in a way that is consequential for their welfare. The second part that I'm hoping to illustrate in this talk is that sometimes we think of the technologies as isolated. Do you have access to an electric vehicle or not? Do you have access to an e-bike or not? But very often, the enabling infrastructure that surrounds these technologies plays a critical role in whether or not people can access them. And sometimes those critical technologies are things that we think of as unrelated to energy technology. So for example, do you have access to wireless internet or not? Do you have access to banking? Do you have access to mobile banking? Do you live in a place that is safe, where you have access to public safety. The other key insight from this is that we need to start co-designing infrastructures that we tend to think of as separate. And I'll elaborate on this point with a couple of examples. And the last point here is that access to energy service is not the same thing as access to energy. The point here is if we try to achieve equity by replicating the ways in which people who are currently well off, either within countries or across the world, if we try to make sure that everyone has the same level of access to cars, if we make sure that people have access to the same kind of housing, the same amount of heating and cooling, then we're not going to be able to transition to a net zero economy. We have to focus on providing energy services rather than energy. So, for example, in the case of transportation, we need to make sure that people have access to efficient, affordable transportation. And the best way of doing that may not be to give everyone equal access to private cars, for example. So with that long preamble, let me get started with some of the empirical results that I want to talk about. The first point that I made was that there are currently significant disparities in access to energy. And this is a relatively recent study. This is a study that I've previously presented at the Green Home Institute. And what this showed was that if you look in Wayne and Washtenaw counties and you plotted people's energy use per occupant in the house, you find that people with lower incomes actually use more energy per unit floor space per occupant. This may seem somewhat counterintuitive, and it leads you to wonder whether people are making poor decisions. Are they not controlling their thermostats properly? Are they trying to stay too hot, too cool? And we actually had thermostat data for these households, and it turned out that that wasn't the case. People, regardless of income, kind of used their thermostats in the same way. Their set point temperatures were similar. The temperature in the house was similar. The extent to which they changed their set points was similar, regardless of income. In fact, you see that low-income households sort of aggressively change their set points, adjust their set points in order to manage their energy use and trade it off against comfort. And you also find that the internal temperatures in the homes of folks on low incomes actually vary quite a lot. So people are actually willing to put up with discomfort in order to manage their bills. And so the question is, why are these people actually using more energy when they're trying actively to try and use less? And the answer is that their homes are less efficient. We actually show this in the study, which again is freely accessible at the links in the slides. You can just download it for free. The clue is in these blue bars here. These were homes that were retrofitted by Habitat for Humanity in Wayne and Washtenaw counties in the Huron Valley. And these are among the most efficient homes in our sample, even when they're low-income homes. And so what this shows is that if you actually make these homes more efficient, folks on low incomes actually end up using less energy per capita than folks on higher incomes. It isn't their behavior, it's the fact that they're living in less efficient homes. As more evidence of this, my colleague Tony Reams, many years ago now, published a really interesting paper where he visited stores in different neighborhoods in Detroit and tried to look at whether people could buy LED lamps in those stores, and if they could, what the price of those LED lamps was. And what Tony found was that in low-income neighborhoods, in neighborhoods where there was a high proportion of people living in poverty, one, you were less likely to be able to buy LED lamps versus incandescent or fluorescent lamps. And if you could find them, these lamps actually cost more in lower income neighborhoods than they did in higher income neighborhoods. And this has a little bit to do with what kind of stores are available in different neighborhoods. But nonetheless, this does mean that folks with lower incomes have poor access to clean technologies, just as they have poor access to efficient housing. To kind of change the context a little bit and to illustrate the point about intersectionality, this is a study that was done by a group of researchers at Cambridge University, and they went to India, to Mumbai, which is my own hometown. And what Mumbai has done over the last decade or so is to try and rehouse people who live in slums. Around 50 or 60% of Mumbai's population used to live in slums until quite recently, until about a decade and a half ago. And naturally, the government was embarrassed by this and wanted to try and improve people's living circumstances. And so it constructed these really high-rise tower blocks and essentially forcibly moved people into these tower blocks and bulldozed some of the slums, not all of them. And these researchers went to these tower blocks and tried to understand how the people who live there use energy. And they found several interesting things. So here they've described a set of layouts for these tower blocks. Obviously, the state is trying to pack in as many people as possible, so these are not large homes. But what you see is that in the majority of these designs, most houses don't have cross ventilation. They don't have access to cross ventilation. The homes are open to the outside, at best in only one direction. What that means is that these people who are often desperately poor have to pay for mechanical ventilation, have to pay for mechanical cooling, including air conditioning. And in many cases, access to power is unreliable, access to power is costly. And so you can see a bunch of cables here. In many cases, people actually illegally tap off power from nearby distribution points, which raises the risk of electrocution and the risk of fire. In some cases, when people have access to ventilation, they actually build cages around the windows that look like this. And the point of these cages is twofold. One, this is to kind of keep out urban animals. You have birds of all kinds, and in some cases you might even have monkeys who might be able to get into your house if you keep your windows open. So people build these kind of cages, and they also then use them as storage because the homes that they live in are really small. Now, what does this have to do with energy use? So the first thing it has to do with energy use is that with the limited ventilation you have, these people are forced to create barriers to those windows so that the ventilation is even further reduced. In this case, this house has windows that can be fully open. The building on the right, but the building on the left actually has sliding windows. So the windows can't even be fully open. What this means is that it creates this desperate need for mechanical ventilation for these people. And the way this interacts with gender is the following. Because running these air conditioning units or running a fan is expensive, what often happens is that people have to ration the amount of time they run the air conditioning for. Usually in these households, the man in the house and the children leave the house at 8 or 9 or 10 in the morning to go to work or to go to school. and the woman in the house basically is at home throughout the day, including in the hottest part of the day, in the afternoon. And in order to make sure that the air conditioning is available for the children and available for the man, this is a gendered decision. Often the woman of the house does not use air conditioning throughout the day, even though she's exposed to the hottest part of the day, and the air conditioner comes on when the children and the husband arrive in the evening. So this is a case where a well-intentioned scheme to actually provide people with decent housing did two things. One, it wasn't designed in a way that would minimize people's energy use. And so that created a need for mechanical ventilation for these people. And secondly, because the buildings were also poorly designed, and because of the cultural norms within the society, it resulted in women having poorer access to this technology than men did. And so this is an example of that intersection between two dimensions of equality, gender and income, sort of working out pretty badly for people who are at the intersection of them. In our study in Wayne and Washtenaw counties, we certainly came across households which had really high energy burdens, but where there were young children present. And a lot of parents told us, or at least some parents told us, that they were not able to maintain a comfortable temperature in all the rooms of their house. And so the rooms that they could actually heat or cool effectively were given over to the young children, and the parents actually occupied the less comfortable rooms and exposed themselves to unhealthy and uncomfortable temperatures. Now, to talk about another technology, and basically as a segue to talk about the importance of enabling infrastructure, I'll talk a little bit about access to EVs. There's quite a lot of work which shows that EVs are about the lowest cost vehicles you can own, especially with federal subsidies over their lifetime. This is a report from Consumer Reports from 2020. The numbers are probably even more favorable to EVs now that there are federal subsidies, and there are now several low-cost models, including used models that are available. And so you would think that EVs would be particularly appealing to low-income households, but a barrier to EV ownership, and multiple surveys showed this, is that people are unwilling to adopt EVs because they know that their access to charging is poor. And this is particularly important for those who live in multifamily housing. One relatively early empirical study of this from a couple of years ago looked at zip codes in New York City and compared zip codes where there was access to EV chargers with zip codes that did not have EV chargers. So the first thing was that zip codes that have chargers tend to have a fairly high white identifying population. They tend to have a low black identifying population if they have a charging station, and they tend to be close to highways. And this is really the kicker in the study. What this shows is on the x-axis the percentage of the non-white identifying population and the number of EV charging stations within a particular zip code. And this is plotted for two income groups, for people who have greater than median income and lower than median income. What this shows is that if you have lower than median income, then it doesn't matter. It doesn't matter what the racial composition of that zip code is. They have basically pretty poor access to EV chargers. But among high-income groups, access to EV chargers improves dramatically as you reduce the proportion of the white identifying population. So even if you sort of control for income a little bit, you find that non-white populations have poor access to EV chargers. This was in New York, and you see the same pattern repeated in California, where people of color have live in places where there's worse access to chargers, even if you control for incomes, distance to the nearest highway, and whether they live in multifamily households. So even if you control for all of that, it seems that both in New York and in California, and no doubt in a lot of places in between, race determines the extent to which you have access to chargers. Now, access to chargers is not the same thing as access to charging. This is where the role of enabling infrastructure plays a role. About 6 million households in the US are unbanked. They don't have access to a bank account. Unbanked rates are higher among lower income households, less educated households, Black households, Hispanic households, households with disability, and single mother households. And differences in unbanked rates between Black and white households were present regardless of income level, across every income level. Now, it turns out that about 20% of the attempts to charge in San Francisco, according to a recent study that was done in 2022, 20% of those attempts to charge your electric vehicle in San Francisco failed because of problems related to payment, which means you have to make an electric payment. You don't have electric chargers where there's a shop nearby where you can actually go and pay for your electricity. You have to do it using some form of online payment. And about half of the charging attempts failed because there was a need to contact customer service by phone. And what data have shown is that both access to banking and to wireless banking, access to mobile phones, is poorer for low-income households. If you have an household income of $30,000 or less, there's about a 30% chance even today that you don't have smartphone access to your bank account, which means that you can't really use an EV charger at all in most cases. The other barrier to using infrastructure, and this is a series of studies that looked at access to transit, which again is an important decarbonization technology. It's an important green technology. What this study found is that in multiple locations, in multiple different contexts, women, for example, fear for their safety and are therefore unwilling to use public transit, are unwilling to use bicycles after dark. So this was a study that was done in London, admittedly about a decade ago. And what it found was that if you ask women and men about whether it feels unsafe to use transit after dark, the proportion of women who say that they find it unsafe to use transit after dark is twice as high as the proportion of men. And the story sort of repeats itself in the US. This is a study that was done in the US. These are actually leaders of women's organizations across the US, and they were interviewed to talk about their members' experience of using public transit. And what you see is that, again, this is a technology, this is a green technology that women are unable to use because the public spaces are not perceived to be safe enough after dark. So that shows that there are multiple enabling technologies, both physical and also just in terms of infrastructure, that prevent people from using green technologies. The third part that I wanted to talk about was the importance of co-designing infrastructure. This is probably a topic that folks who attend a Green Home Institute webinar will not need an introduction to. But this is a study that was done in California, which looked at the hosting capacity of feeders of two large utilities in California, Pacific Gas and Electric, and Southern California Edison, to understand the ability of feeders to add load. You might want to add load if you're electrifying your heating, for example. If you're electrifying a heat pump, you might want to add load if you're adding an EV charger. And there are no clear trends in the Southern California Edison area. But if you look at PG&E, as the proportion of Asian or Black residents increases, the capacity of the feeder that serves that area to add load diminishes, which means that if you are Black and you live in PG's service area, the power system itself is set up so that you wouldn't be able to add a heat pump dryer. You wouldn't be able to add an EV charger to your house without the utility actually upgrading its distribution network. And that disparity is replicated for your ability to add PV, and it is replicated to a smaller extent for your ability to add PV if you promise that you are not going to send any power back to the grid. So there's infrastructure that people do not directly interact with that kind of limits their ability to adopt green technologies. One more example of this, the power system consists not only of the physical infrastructure, but also consists of the software of the power system, so things like utility rates. This was a study that was done, I think, using data out of Arizona, which put people, or used a natural experiment where people were on different rates. They were either on time of use rates or on a flat rate that was a control rate. And this measures their change in electricity bills once they went on the time of use rate. And it further splits that change into people who belong to a vulnerable group and people who did not belong to a vulnerable group. So the black line is for people who belong to a vulnerable group, and the white bar is for people who didn't. What you can see here are the vulnerabilities that the people face. And this is data for folks on low income. This is data for the elderly. This is data for young children, and this is data for people on disability. And what you see here is that if people are on low income and you put them on a time of use rate, their bills do not really go up if they're vulnerable, or they do not go up, or they go up less than they do for people who are not vulnerable. And the other three charts here give us a clue as to why this happens. Basically, if you're low income, you actually try to control your use of energy, in this case, through your use of air conditioning, so that you actually consume less. And so you can actually manage the increase in your bills. But if you're elderly and you actually need access to cooling in order to stay healthy, then you're not able to cut your use of energy to the same extent. And the effect of that is that your bills go up more than they do for people who are not elderly. The same is true for young children. You may not be able to cut your energy use quite as much if you have young children at home. And so your bills go up relative to people who don't have young children. If you have a disability, which means you're not out working during the hottest part of the day, you don't have the ability to cut your energy use in response to these TOU tariffs. And so your bills go up relative to someone who is able to stay out of out of the house when it's hot. So yes, we need to, when we transition to green technologies, in order to make sure that that transition is equitable, we need to think about the physical infrastructure. We need to think about systems that interact in ways that they did not before. And we need to make sure that those interactions are equitable. The last point that I wanted to make, the last key takeaway, was that access to energy service is not access to energy. One example of this is given here in the case of transportation. This is work that was led by Max Woody, who's a student here at SEAS. And Max basically did some analysis to see how EV car sales would evolve over time and how the stock of EVs would evolve over time, because cars last 20 or so years. And what Max found was that even when we get to essentially 100% or more than an 80% EV sales, which this analysis predicted would happen sometime towards the middle of the next decade, the stock of electric vehicles for cars and trucks would be somewhere between 20 and 40%, which means somewhere between 40 and 80% of the vehicle miles that we drive would still be conventional vehicles. And so if we wanted to decarbonize, if we wanted to substantially decarbonize transportation within that time frame, we can't just take all the cars that we have and wait for them to become electric. Even if we have a perfectly clean electricity grid, there's still going to be a lot of internal combustion engines around. And what we actually need to do is to get people out of those cars and reduce vehicle miles traveled. And that point is kind of made very explicitly by the study led by Abdullah Al-Arfaj, who was a student at Carnegie Mellon, and Costa Samaras. What this study shows is that if you wanted to cut emissions by 80% from light-duty vehicles, then even if you had a perfectly clean grid, carbon intensity of 0, you would need 63% of EV miles to be electric, assuming that you wanted the same level of travel that we had in 2018. If you assume that VMT increases at historical rates, then more than 70% of all vehicles would need to be, or all miles would have to be electric. And that number kind of skyrockets as the grid gets dirtier. Just for context, this graph kind of maxes out at 200 grams of CO2 per kilowatt hour. The current CO2 intensity of the grid is more than twice that. It's 400 to 600, depending on where you are in the country. And so what this study showed is that if you actually eliminated all the urban vehicle miles traveled, if you moved everyone in the 10 most densely populated parts of the country to public transit, then you could get to an 80% reduction in light vehicle transport with only 50 to 60% EV miles. So all of this is to show that we can't simply keep doing what we're doing, but do it in a way that is deemed to be cleaner and still get to our decarbonization targets. This is another example of air conditioning. This is a study that was done by a group at Columbia University. And what they did was to get the daily peak power load in different cities across the world to look at the temperature at which the load took off. And so they identified this point, the point at which the load becomes strongly dependent on temperature, as the point at which buildings in that city start to use air conditioning in a big way. And what you see here is that threshold temperature in New Delhi or in Singapore is in excess of 20 degrees centigrade. the point at which people start to use air conditioning extensively. In places like San Diego and Los Angeles and New York, that temperature is 12 degrees centigrade. So if it is 12 degrees centigrade outside, these cities actually, the buildings in these cities actually start to use air conditioning. And so we've got to question about not just how we design our buildings, but what our expectations are about the level of comfort in an indoor space and what we need to do to ensure that level of comfort. So, of course, if you wanted to do this in an energy efficient way, there's a number of things you could do. You could adjust your thermostat so that this transition did not happen at 12 degrees centigrade, so that people within buildings actually accepted warmer temperatures, 78, 80 degrees rather than 68 degrees, for example, during the summer. If people undertook adaptive behaviors, in this case, if you live in a warm climate, you probably want to be able to open windows, for example. There was a review done of how people in the global south cope with high temperatures, and one of the things that was highlighted in that review was food choices. It turns out that eating spicy food actually makes you feel cooler, and so that is one of the ways in which people adapt. Also, fabric and clothing choices. This is something that that folks in the global south, so for example, in Africa and to some extent in Japan, have started questioning that do you actually need to wear Western formal business attire, suit and trousers and tie and so on, in the summer where it's when it's really warm, and then use air conditioning to cool yourself. In many cases, there's an attempt to rediscover vernacular architecture. So these are architectural practices that were adapted when mechanical cooling was not accessible to people. Now that mechanical cooling is widely available, people have abandoned these practices, and you see sort of steel and glass towers in a lot of places where it's really energy intensive to build that way. And of course, there are a large number of new cooling technologies that are not yet explored. Vapor compression is the dominant cooling technology, but there's a whole lot of other cooling technologies that are at different levels of technological readiness that could be adopted. So with that, I'd like to sort of recap the 4 takeaways. One is that there are disparities in energy access today and in access to green technologies along multiple dimensions. These disparities are really acute at the intersection of different dimensions, for example, gender and income. When we think of expanding access to green technologies, we have to think about what enabling infrastructure that requires. Sometimes that is stuff that seems unrelated to energy technologies. So things like banking, wireless internet, the provision of public safety. We need to start co-designing infrastructures that we have historically thought of as separate. And finally, we can't give everyone access to the same specific technologies and still remain sustainable. We need to think about what services those technologies provide and find efficient ways of making sure that people have equitable access to the services rather than to only the technologies. So that's all I've got. Brett, I see that we have a few questions.
Yeah, hey everyone. We do got a couple questions here, and we got a little bit of time to get to those. Parth, are you able to stick on a little bit after past 1 to answer some of these questions?
Yeah.
Okay, great.
Yeah, sure.
So yeah, before we get to those questions, just a real quick reminder that yes, this course is being recorded and it'll be available up on our YouTube channel, so you can share that or access it later if you want to rewatch it or missed some of the course. And so you can go to our YouTube channel right now and click subscribe. You'll get a instant update when it is available. Otherwise, you can check back there in the next couple of days, and it will be available for you. Sorry, I was trying to pull up on where you can access it, but I'll just drop it in the chat in a little bit. And then just as a reminder, for those of you watching this in the future, not right now, but on demand, make sure to take your quiz with an 80% passing rate, and then you will receive your continuing ed certificate for doing that. And those of you watching here today live, make sure to check your spam at certs@gutenbergcerts.com. You'll receive your continuing ed certificate there, and then take the survey that pops up as well to report AIA and help give us feedback on our session. And real quick thanks to our board of directors, our volunteers, our executive director, Jose Reyna, our over 300 members who support our work, and our sponsors, especially our top tier Platinum Plus sponsor, Ream, for helping make products that decarbonize and help us ultimately save energy. So yeah, let's get into some of those questions that came up. I think you kind of started, getting into the equity issue about EV charging stations. So that was kind of a question that came up about how multifamily housing properties, especially ones that are HUD or don't have access to this. The other question that kind of came up and concern that came up with these affordable housing projects not typically having solar or long-term storage. So I think the question is kind of what resources or incentives are you seeing, or are they being put out there to make these kinds of technologies, such as the charging infrastructure or solar or storage, again, anything to help with some of these time of use rates?
So on access to charging, I think Adewale might have had a response. So Adewale, I just want to check.
Oh, he had to leave early,
something...
so he's gone.
Okay. I'm sorry. Yeah. So I think this, in many cases, this just needs to be built into regulations in countries that have been successful in, for example, encouraging EV adoption. They've basically made this sort of quasi-right. You have the right to ask for it. Everyone kind of builds for access to EV charging. I think the last set of numbers I saw from China was, I think, in April, and I think it was 45% of new vehicle sales were electric in China. And one of the reasons why that has happened is that if you live in multifamily housing, basically whoever owns that housing and the utility are just required to provide you with adequate charging. You just have to do that. So some of this needs to be written into regulation. And in the US, it's harder to probably regulate the private sector, but this is certainly something that the government should do in making this available. One of the challenges is that for a private provider, this becomes a kind of a chicken and egg problem. If there aren't a lot of people who have EVs, then the economics of your EV charging station are really very bad. And so, do you actually provide it and eat the losses for a number of years? So from the point of view of a government, you not only have to subsidize the initial installation of the infrastructure, you may have to subsidize its upkeep, you may have to regulate its upkeep. And so, there's more to the problem than saying that this infrastructure should simply exist and we'll pay for it to exist. Yeah. for a lot of these things, Bill, the bipartisan infrastructure law actually provides incentives to address some of these things. So they are being tackled, but there is no doubt that we need to do more.
Yeah, and that's interesting when you pointed out that there has to be almost like when they mandate parking spaces, right? And there's a lot of concern with that. But when they mandate parking, they mandate parking spaces for housing. You're just saying that perhaps they add in the component of the charging, right? In that same kind of concept.
That's right. And I'm sure a lot of folks on the call know this, but one of the ways of doing this is to use utility lighting poles. It turns out that when lighting switch from sodium vapor to LED, obviously you're using a lot less energy, and so there's excess capacity to be able to supply these poles, and you can use some of that capacity for EV charging. This is being done quite a lot in Europe, is my understanding, and is now being done in parts of the US as well, and there are creative solutions. So, one of the ways to deal with the sort of maintenance aspect and the economics aspect is to do it as cheaply as possible.
Yeah. Another question came in is, if vehicle miles are reduced by decreasing the total number of vehicles, thus forcing people to use community transit, are there knock-on effects in terms of illness transmission, perhaps, thinking of, future pandemics or anything else, and lost time through excessive mode routes of transfer accounted for anywhere in this lost productivity and resulting in energy loss?
Yeah, so there's a couple of things. I haven't looked at the details of it, but my understanding is that the evidence on disease transmission in transit is pretty mixed. There's not a lot of evidence that there was a huge amount of transmission through the use of public transit. If you look at health outcomes, places like Japan, places like Singapore, where car ownership is really difficult and expensive, and transit use is nearly universal, they actually had pretty good health outcomes during the pandemic. So I think there's ways to adapt to that. In terms of productivity, that's a really good point. We actually are working on a study where we're trying to understand. We're looking at Uber and Lyft trips in Chicago and trying to understand what would have happened if each of those trips had been done using transit. And it turns out that these are unpublished results, so this might all be wrong, but what we're seeing initially is that if you kind of monetize the productivity loss, it exactly compensates for the additional cost of using Uber and Lyft. So that's a point well taken. But the solution to this really is to improve the quality and frequency of transit. I live in Ann Arbor, and the quickest way for me to get to work is to bike. The slowest way for me to get to work is to ride the bus, and driving comes somewhere in between the two of those things, because I work in a crowded downtown. Parking is a nightmare. So if I bike, I just go straight to my office. If I took a bus, it's 5 steps away. If I try to park, who knows where I might park, and there might be sort of an additional 20-minute walk to get to my office. So I don't think the productivity question is also a slam dunk. I think if you have good quality transit, that can actually be more productive than using cars. And we sort of ignore the productivity killers that come with car ownership. The oil changes and getting gas and the repairs and all of that. So there's I think the productivity equation is not a slam dunk if you have good quality
Yeah.
transit. It's certainly a problem if you have poor transit.
Yeah. So if I understood your time of use chart, and for those who are, experiencing poverty or income situations, you're saying they fared okay under the time of use program. Just on that chart, there were other different types of people with different situations you listed who didn't. But you say they fared okay because they perhaps were able to make the necessary adjustments to save energy, such as reducing AC. Did I hear that correctly? Yeah.
That's right. So basically, they tolerated more discomfort, and that has health impacts.
Yeah, that's what I was getting into. Is there still a trade-off of, heat waves come and you're asking people to reduce their health, and they're thinking, or even humidity of course harms your health, but it can also damage your building. You can have dew point spikes, mold issues. I mean, was that discussed, looked at in that study or part of the conversation at all?
I think the study did look at outcomes, and outcomes were worse. It obviously focused on outcomes for the elderly, folks with disability, children, because those things are there's data about that. But yeah, it is absolutely the case that there's a set of people who are healthy enough that if they accepted some harm to their health, they figure they would still be able to survive, and are willing to make the trade-off. And as the climate warms, that that margin that you have to say that, okay, I'm for 3 or 4 hours, I'm just going to be uncomfortable. The margin for you to do that without sustaining harm will shrink.
Yeah. So another kind of question came in here, and it was, to your point about access to service versus access to infrastructure. Do you feel like this sentiment is well accepted among the environmental organizations right now? Speaking with a US bias here, but it feels like there's a lot more acceptance about a technology solution like EVs, or I'll even throw in heat pumps. We go heat pump crazy. Then there is about social change, like driving public transportation, or reducing your heating and cooling. How much of these design solutions are contingent on cultural change?
I think they're absolutely contingent on cultural change. I think maybe what is missing is the two studies about the EV vehicle miles that I showed. I think people don't talk so much about cultural change because they feel that it'll be slow, impossible, politically difficult. But the problem is that even if we make really optimistic assumptions about the rate at which the technology can penetrate, the technology alone doesn't get us there. And so it's not an either or thing. We actually have to have the cultural change and deploy the technologies as fast as we can.
And in some ways, I feel like some of these technologies are a cultural change, right? I mean, you to some extent are changing. If you're driving an EV, you are changing what you're doing, right? so those two kind of go hand in hand. So we are
That's right.
I don't see any other specific questions right now, Parth, but what would you share with us working on next that people might want to be aware of or think about, that maybe you'll be having some more material on in a little bit?
Yeah, so a couple of things. One is the study that I just mentioned on the trade-off between time and cost and environmental burdens associated with transit versus taking Uber and Lyft. So we'll have some fairly granular data there. The second study, which we've wrapped up, is we interviewed 50 homes in Wayne and Washtenaw counties after they got a very comprehensive energy audit with a blower door test and a set of recommendations that told them how they can fix their homes. And we went and talked to those people to try and understand what they did with these recommendations. Are they useful? Are they not? And so there's work on that. And my student, Claire McKenna, should be able to present on that in the next quarter or so. There's also some work on whether partial automation of trucking creates room for us to electrify more trucking. And I won't go into a long and tedious explanation for why automation might help electrification, but there's some ongoing work on that question as well.
Yeah. All right. Well, great. I guess as a wrap up here is, where can people go? I see, I mean, you've linked all of these different studies. Do you reference any of these on a website of yours on your bio at University of Michigan, or just maybe people should just go back to the handout and find the studies there? Is that the best place to find them?
Yeah, so I think maybe this the best thing to do is to look at the annual reviews papers,
Okay.
both the one by Paul Mahai and mine. And those have a whole bunch of studies referenced there. And there are diagrams which are easier to follow on the page than they would have been on the slide, which give you a sort of map to all the studies that were listed. So you can then pick the one that is interesting to you and go and pursue it further. You can also always contact me by email. It's on the first slide of this deck.
Yeah. All right. Well, Parth, thank you so much for your time. And thanks to Adewale as well, who had to go. And thank you all for tuning in. We will catch you at our session here next week. So goodbye. Take care.
Thank you very, very much.
Be sure to check out all of our courses available online that you can watch anytime and anywhere to pick up your CEUs. Before you go, make sure to subscribe to us on YouTube to get weekly updates and stay up to date on green building science courses, webinars, and home tours. Thanks again.